Hello children, welcome to 7th Science online classes. Chapter 6 Physical and Chemical Changes. So in this lesson, we studied many examples of physical and chemical changes. And today we are going to see another important chemical change, that is rusting of iron. Rusting of iron is a chemical change. You might have seen some old iron objects at home, like some iron tools, iron nails, iron gate. Okay, you would realize that these objects have turned reddish, unlike their original metallic color. So just think about a fresh nail. What is the color of the fresh nail? That is a silvery appearance. But when you keep that iron nail, that fresh iron nail, outside, or that iron nail contact with atmospheric oxygen, its color changes from that metallic or that silver color to a reddish color. This is what we call rusting of iron. So that rust formed and that coated on that fresh nail, that is rusting of iron. And we will see what is the how it formed, how rusting of iron formed. For rusting, the presence of both oxygen and water, or water vapor or moisture, is essential. So this is important for rusting, the presence of both oxygen and water, then only rusting formed. Okay, so when we keep an iron article outside, that iron article contact with atmospheric oxygen. Oxygen is present in the atmosphere, so that iron article contact with that oxygen, atmospheric oxygen, and in our atmosphere a water vapor or moisture content is there, that enhances the formation of rust. Then the process of rusting can be represented by the following equation. So we can represent this rusting, that chemical change, through an equation, chemical equation. See, iron, the symbol of iron is Fe. Symbol of iron, Fe. Fe means actually it is ferrum. In chemistry we are using that word ferrum, but you no need to study that one. You just understand this one, iron, and symbol is Fe. So iron react with atmospheric oxygen, O2 from the air or from the atmosphere, plus water. Water is the water also moisture content or water vapor in the atmosphere. So iron plus oxygen plus water to form rust. So chemically we can call rust like this, iron oxide or Fe2O3. This is the chemical name. Iron oxide is the chemical name, and this is the chemical formula, Fe2O3. Clear children? So rusting, for rust, which are the things necessary? Oxygen and water. Okay, so chemical equation also, iron plus oxygen plus water to form rust. Common name is rust, chemical name is iron oxide, and chemical equation is Fe2O3. This everything you have to study. And here this equation also we just see, this is the iron, fresh iron. You look at the appearance of this fresh iron, it's look like a silver chain. Okay, and it react with atmospheric oxygen, that is O2, and react with water vapor, that is H2O, to form rust. So see the color, that is a reddish brown color. So that is because of the formation of rust. So this rusting of iron, that is a chemical change, and this is very, very important. Next, how to prevent rusting of iron? How can we prevent? How can we stop rusting of iron? First point, by applying paint or grease on iron objects so that they cannot come in contact with oxygen and moisture in the environment. This is very familiar to you. At your home also, you are painting the iron things to protect the iron objects from rusting. So I'm reading once again: by applying paint or grease on iron objects so that they cannot come in contact. So when you applying paint, that paint acts as a barrier, and this iron article cannot contact with atmospheric oxygen and water vapor. So in this picture also it's clear. Next process or next method of preventing method is galvanization. Okay, very important term, galvanization of iron, which means applying a layer of zinc or chromium metals on the iron. So in the first point we apply paint. In the second point we apply zinc or chromium metals. Okay, that process is called galvanization. So this everything, the detail you will study in the higher classes. Now galvanization means applying zinc or chromium on iron. So like we can protect iron from rusting. So probably you can see the metal or this type of pipes. These pipes galvanized using zinc or chromium metals. Then next point is by alloying iron with other metals or non-metals. So you are learning a new word, that is alloying. ALLOYING, alloying. Alloying means iron is a metal. So that metal mix with another metal or another non-metal. That process is called alloying, and that objects are called alloys. Example: stainless steel. Stainless steel is an alloy of iron with carbon, chromium, nickel and manganese. This is also very important, children. Stainless steel. Stainless steel is the mixture of iron mixed with carbon, chromium, nickel and manganese. So you have to by heart these names. Okay, stainless steel means iron mixed with, iron is the metal, we want to protect iron, so we mix the iron with carbon, chromium, nickel and manganese. Stainless steel spoon, glass, plate, that is in your kitchen, so that is stainless steel. That stainless steel is the mixture of iron mixed with carbon, chromium, nickel and manganese. So very important, so you have to by heart this also. Next is ozone. You know that is a protective shield of Earth. In this picture, this ozone layer acts as an umbrella. See, ozone protects us from the harmful ultraviolet radiation which come from the sun. You know that sun radiates some energy as ultraviolet radiation, then infrared radiation. Many radiations are there emitted from the sun, and some these radiations are harmful to the earth. So this ozone layer protect us from this radiation, this harmful radiation. Ozone absorb this radiation and breaks down to oxygen. Okay, so here what is the chemical process happening here? Ozone absorb the radiation emitted from sun. So ozone absorb the radiation and breaks oxygen. Oxygen is different from ozone. So ozone is actually O3. So that time when it absorb, it break down to form oxygen. So breaking down of ozone is a chemical change. So chemical change means a new product is formed. Actually ozone is O3. That everything you will study it in late next higher classes, but I'll just tell about it. Ozone is O3. The formula is O3. and when ozone absorbs this radiation, it changed to O2, that is oxygen. So there is a chemical change. So the breaking down of ozone is a chemical change. So that is another example of chemical change. Ozone is a chemical change. Next, we are going to study a physical change, that is crystallization. So we studied many chemical changes. Okay, through chemical changes, new products are formed. But in physical change, no new substances are formed. So crystallization is a physical change. Now we will see what is crystallization. In class 6, you have learned that salt can be obtained by the evaporation of seawater. Evaporation technique or evaporation method. So through this evaporation, that we just boil the salt water and we get the salt. So that salt is not pure. But using this process, crystallization, we get a pure crystal form of substance. Crystallization is an example of physical change. It is a process of obtaining crystals of a pure substance. That is the important term in this crystallization. Through crystallization, we get pure substance from the solution. One example, we can obtain the crystals of copper sulfate by boiling copper sulfate solution. So how we can get pure form of copper sulfate crystals from copper sulfate solution? By using this crystallization method. So for that one, first we first we dissolve this copper sulfate in water. So it dissolve, again add powder, copper sulfate powder, again, and we add that in water. After that, we just boil it and keep the thing for half an hour or for 1 hour without disturbing. So after that, we will get crystals of copper sulfate. Okay, so we will see that video also. See, adding copper sulfate powder in water. Again adding copper sulfate in water, stir well, and that copper sulfate powder dissolve in this water very well, and you can see the color also, blue color, copper sulfate blue color. Then boiling, okay, using this spirit lamp, boiling, and after that just pour it into this another glass or another beaker, and you can see that a pencil on the top and a thread is here. See, after a while, see this crystals of copper sulfate. This is copper sulfate crystals. Got it, children? Again, copper sulfate powder dissolve in water and boil it. Okay, and after boiling, pour that copper sulfate solution in another beaker for cooling, and keep one thread also inside that beaker. After a while, you can see that the copper sulfate crystals are formed on that thread.